Welcome back. I'd like to do another example of graphing a quadratic function using vertex form. Now remember, vertex form is the form y equals a times x minus h squared plus k. And the advantage of writing it in this form is that the vertex can be read right out of the equation. So let's start with this example. This one will be a little bit different than the other example that I did for you. So I want to sketch the graph of f of x is equal to 2x squared plus 2x plus 5. And as before, I want to find the vertex and any x and y intercepts, and any intercepts. Okay, so what I would like to do to start with is again replace f of x with y, because y is again the same as f of x, and I'm going to rewrite the function as y equals 2x squared plus 2x plus 5. Again, I want to be able to complete the square, so my first step is to move the constant to the other side. So this is going to become y minus 5 is equal to 2x squared plus 2x. Now we have the x squared and x term by itself on the right-hand side, and we can complete the square. But there is a problem with this. Notice that we have a leading coefficient of 2 here. When you have a leading coefficient other than 1, you may not complete the square. It doesn't work. So the first thing we need to do is rewrite this so it does have a leading coefficient of 1 with the x squared. Now we are rewriting the equation, so the only way to do that is to actually factor the 2 out of the terms we have on the right-hand side. So it's going to look as follows. Y equals 5 is equal to 2 times the quantity x squared plus x. Now I am ready to complete the square. So if we remember how to do that, again, we take 1/2 of our b value, which is 1 here. So 1/2 of 1 is still 1/2. And if I square it, I'm going to get 1/4. So the value I need inside the parentheses here is a plus 1/4. Now here's the tricky part that's different than what we did in the last example. Remember, when we add something to one side of the equation, we must add it to the other side. The problem is we didn't just add 1/4 to this side. We added it inside the parentheses, but what we added to this side is actually 2 times 1/4. So when you factor out a leading coefficient, you need to make sure you include that in order to balance the equation. So if I have 2 times 1/4, that's equal to 1/2. And so what I need to add to the other side then is a 1/2. I am balancing the equation, but I have to take that 2 into account. So now I'm ready to finish rewriting the equation. So this is going to become y, well, let's see, 5 is 10/2. So if I add a 1/2 to that, I'm going to get a minus 9/2. Yes, we are going to deal with some fractions, is equal to 2 times, and now factoring this may not seem quite as straightforward either, but if you do write your 1/2 b off to the side here like I did, this 1/2 b is always what completes the square binomial. So it is a plus, and I get x plus 1/2 squared. We're almost done. All we need to do now is bring the 9/2 over. So we get y is equal to 2 times x plus 1/2 squared, and then we add the 9/2. So Now that we have it in vertex form, we can read off the vertex. The vertex here is going to be, now remember the plus 1/2 moves it to the left, so we have negative 1/2, and the 9/2 moves it up, so negative 1/2, positive 9/2. So there is the equation rewritten in vertex form, and we have the vertex. So the next thing I want to do is find the y-intercept. I always find that easiest to find. So the y-intercept, remember we want to let x be 0. So if I go back to the original equation, which is the top one here, it's easiest to find the y-intercept. So we have y is equal to 2 times 0 squared plus 2 times 0 plus 5, and that all simplifies down to 5. So my y-intercept is at 0 and 5. Now today I want to kind of look at just graphing it at this point. Last time we actually sketched the graph when we found all the intercepts, but I want to look at it in a slightly different fashion. So let's get our graph here. And remember, the vertex we found was actually negative 1/2 and positive 9/2, and our y-intercept was at 0, 5. So if I place those on my graph, I have to go a little bit in between my values here again. Here is negative 1, so negative 1/2 is halfway in between. I'm going to go up 4.5. So it's right about there. It's halfway between 4 and 5. And there is my vertex. My y-intercept is at 0, 5. So there is my y-intercept. Now looking at those 2 points, you can get an idea that this graph is going to open up something like this. So I want to be a little bit more accurate in my sketch, so I'm going to dot in my axis of symmetry because it helps guide me. Now 0, 5 is halfway on this side of the axis, so I know another point is going to be halfway on the other side. So I can use those 3 points and get a pretty decent idea of what my graph is going to look like. It's going to be something like that. Now notice that when you look at the graph, you can clearly see that there are no x-intercepts. And that may sometimes happen with some of the equations that you're asked to graph. So algebraically, what does that look like? Let's say you waited until after you tried to algebraically find all the information to sketch the graph. Well, let's go back to that. So if I want to find the x-intercepts, remember I let my y be 0, so I'm going to have 0 is equal to 2x squared plus 2x plus 5. Now if I look at that equation, it certainly doesn't factor, or it doesn't appear to factor. So one way I can check to see if there are x-intercepts is check the discriminant. Now remember that the discriminant is b squared minus 4ac. If I plug in b, I get 2 squared minus 4, my a is 2, my c is 5, and I end up with 4 minus 40, which gives me negative 36. Again, if I get a negative value for my discriminant, that tells me that there are no x-intercepts. So algebraically, that's a way to confirm that there are no x-intercepts. So again, remember when you are rewriting in vertex form, you want to be careful to factor out a leading coefficient, and when you do that, you need to remember to account for that when you're adding values to complete the square. The numbers you'll see on the 2 sides may appear different, but they really do balance out the equation.